Okay, so rules of exponents. Now, I already have a video in the classroom on simplifying exponential expressions. And I briefly have the rules, but I don't really go into detail with the rules and where they come from. So that's what this video is going to be all about, is all those rules, why we have them, what they mean, so all that. So first, we need to work with the definition of what it means to have an exponent, what exponentials are, because I'm going to be using some of this terminology. So A is a real number. So a real number is just any number you can think of. So we're basically working with a number. And then we have the exponent, which is n. It's a positive integer. So we don't have any negatives in this case. And we don't have any fractions or decimals. It's a whole number. It's positive. It could be 0. So that's why we use the word integer. And so that exponent is basically counting how many times you're multiplying your number. So if you have a number like 2 times 2 times 2, and however many times, the exponent is how many times it shows up. So working with an example here, like if I did 2, if I just had a lot of 2's multiplied together, I have 1, 2, 3, 4, 5 2's. So this is equal to 2 to the 5th power. So that exponent just tells me how many of them I have that are multiplied together. So that number is called the exponent. The number underneath it we call the base. And we're going to be referring to these terms quite a bit. Base and exponent. So it's important to understand what they mean and what you are referring to. So A here is the base. So before we get going into the rules, I do want to clarify how you can enter these things in a calculator. And this also works for ALEX as well, as we've got this symbol that's called a caret symbol. It's actually on a computer keyboard. It's above the 6. So you would have to, on a computer, you would hit the shift button and then you would hit 6. And that's what gets you that caret symbol. And you can use that when you're typing into ALEX. You can use that as a shortcut to get to the exponent, so that you don't have to put the exponent button. So that's a keyboard shortcut to get to that button. And so it's just like the top of an arrow. Now, some calculators don't have that button. They have a different button that involves an exponent. And so you do want to make sure you know how to use the calculator that you have. But most of the time, it's that little caret symbol. And it's really important that when you are taking exponents, you have parentheses, especially if you're taking an exponent of a negative. So the example here is -2 to the 4th power, which is another way of saying that the exponent is 4. You have to put the -2 in parentheses, because if it's not in parentheses, then it's going to do 2 to the 4th power and then put a negative in front. So parentheses matter. You should always have parentheses around a negative number whenever you're working on your calculator, just to make sure that you're telling the calculator to do the correct thing. So just a side note about that and how you would put it in a calculator. Just good practice is if you've got negatives, put a parenthesis. So we're going to start with the first property, which is what happens if you have a 0 exponent. So anything with a 0 as an exponent is equal to 1. And so you may be wondering, well, why is that? Why is the rule that if it has an exponent of 0, it's equal to 1? So let's work with numbers. So let's say I have 3 2's multiplied together, so that's 2 to the 3rd power. If I have 2 of them, that's 2 squared. If I have just one of them, that's equal to 2 to the 1st power. And then the question is, well, what is 2 to the 0? So there's multiple ways to think of this. The first way you can think of it is like, well, I can multiply all of these by 1, and it doesn't change because multiplication of 1 doesn't, it just keeps the number the same. So if you follow the pattern, that means that if I don't have any 2's because the exponent is 0 and it's telling me that there are 0 of them, then all I have left over is 1. Because I'm basically removing a 2 each time. Another way you can think of it is if we actually evaluated these. So 2 to the third power is equal to 8. 2 to the second power is equal to 4. 2 to the first is 2. So then what would be 2 to the 0? If you follow a pattern here to go from the first number to the one underneath it, you're dividing by 2. 8 divided by 2 gives you 4. 4 divided by 2 gives you 2. So then 2 divided by 2 would give you 1. So there are two different ways to think about why something to the 0 exponent is equal to 1. First is looking at the pattern of if you're actually writing out the multiplication and seeing that you can always have a 1 there. So if there's none of the actual base, it's 1. Or following the pattern when you're actually looking at what it's equal to. And then you see a pattern of dividing by 2 each time as you go down on an exponent. So then that means, okay, if I follow the pattern, this must be equal to 1. So this is a really important rule about how exponents work. And you can kind of figure it out based off of just like looking at the logic and looking at the patterns. So the second thing we have is what happens if you get a negative exponent. And so a to the negative n, so if you have a negative in the exponent, it's equal to 1 over a to the n. So you basically take the reciprocal of the base. So you're taking the reciprocal of the base, and then you are making the exponent positive. And that's essentially what it means to have a negative exponent. We can rewrite it by taking the reciprocal and then making the exponent positive. And we have two different ways that you can write it. You can put the exponent on a, on the base, or you can put it on the whole thing, and those are equivalent. And why those are equivalent, there's a rule for that later on that we're going to look at is why you're allowed to do that. So negative exponents, you take the reciprocal, make the exponent positive. So let's talk about, once again, why is this true? So I'm going to go back to my pattern that I had before. So 2 to the third power is equal to 8. 2 to the second is 4. 2 to the first is 2. And we know that 2 to the 0 is equal to 1. We just saw that on the previous slide. So then what is 2 to the negative 1? So we saw on the previous slide that as you went down, you were dividing by 2. We kept dividing by 2, and that would give us the next number. 2 divided by 2 gives us 1. So if you continue that pattern, 1 divided by 2 is 0.5, or basically 1/2. And so that is actually, because we have a single 2 on the bottom, we can write that with an exponent of 1. So something with that negative exponent of 1, the reciprocal of 2 is 1 over 2. And then the exponent is 1. It's now a positive 1 instead of a negative 1. And you can follow the pattern again if we had 2 to the negative 2. So once again, you're dividing by 2, And so if you follow, that would be 0.25. Well, how do we get there? We're dividing by 2. You take the reciprocal of our base. Our base is 2, so that's 1 over 2. And then the exponent becomes positive, so now it's 1 over 2 squared, which is the same as 1/4, and 1/4 is 0.25. So the negative exponent is basically indicating the opposite of a positive exponent. So let me write this. So a positive exponent is basically repeated multiplication. And so then you can think of a negative exponent as repeated division. And that's how it ends up in the denominator. So things with negative exponents tend to be fractions. When you actually evaluate them, they have small, because the denominator is getting bigger versus because we're just dividing over and over and over again. So you can watch the pattern. We're dividing by 2, it keeps getting smaller and smaller and smaller as the exponent goes down. Each time the exponent decreases by 1, we've divided our number by the base. So we just keep dividing by the base versus multiplying by the base. So negative exponents, when you understand what they mean, not bad. What people do get hung up with is the rewriting of it right here. So you're just going to want to get used to this rule because you're going to have to use this rule a lot. So it's just something you want to make sure that you have written down. And if it's not written down, memorize or just know that rule because it will come up quite a bit. So our next property is multiplication of like bases. So like bases are where the base is the same. So if you have things with the same base, you add the exponents when those things are multiplied. So a to the m times a to the n equals a to the m plus n. So an example of this, oops, I'm in the highlighter. I don't want to be in the highlighter. If I had 3 squared and then 3 to the 3rd power, when you're multiplying those, you add the exponent. So that would be 2 plus 3, which is 5. So that's equal to 3 to the 5th. This works with an exponent of 0. So if one of them was 0, 3 to the 2nd times 3 to the 0, that's 3 to the 2 plus 0, which is equal to 3 squared. And that makes sense because 3 to the 0 is equal to 1. So you're basically, that makes sense that that rule applies, that works. And it works with negatives as well. So if I had 3 squared times 3 to the negative 3, that's 3, add the exponent, so it's 2 plus negative 3, and you end up with 3 to the negative 1 exponent. So let's see, let's take a look at the first one that I have, 3 squared times 3 cubed, and then 3 squared times 3 to the negative 3 on the bottom one, so we can see that how those make sense. So I'm going to just do it in green here on the left. 3 squared times 3 cubed. So 3, I'm going to just do it backwards. 3 cubed is 3 3s multiplied together. And then 3 squared is 2 of them multiplied together. I can put parentheses around these if I want to indicate. So we have 3 squared, which is 2 3s, and then 3 cubed, which is 3 3s. You add, if you wrote it out, you extended it out, and then you wanted to combine them, you have 1, 2, 3, 4, 5 of them together. So that's 3 to the 5th. So that's why we're able to add the exponents, because when you expand it out, you're basically counting the total number you have, which is addition. And I'll even just for good measure do this one. 3 to the 0 is equal to 1. And then 3 squared is 3 times 3. So you can see that that is equal to 3 squared because multiplying by 1 doesn't do anything. So since we have that rule that 3 to the 0 is 1, it basically, you just, when you add those, it's not really adding anything. You're not adding another 3 to how many you have when you're multiplying. On the bottom, we have 3 squared times 3 to the negative 3. So let's break this one down. We're going to use our rule with the negative exponents. So 3 to the negative 3, you take the reciprocal of the base, which is 3, and then you make the exponent positive. So that's going to be 3 to the third power there. And then 3 squared, so we've got 3 squared. Normally we use from right to left, but because I'm trying to show the steps, I'm just going to go left, or normally go left to right. I'm going right to left just to kind of work out to show why these rules are. So if I were to write this out, 1 over 3 cubed, that is basically you're taking 1/3 and multiplying it out 3 times. And then we've got 3 squared, which is actually 3 times 3. And when you're multiplying a whole number by its fraction, basically those cancel out. So this 3 is on top and this one's on the bottom. Those cancel out because that's one of the rules we have with fractions. Same thing with this one. Those cancel out. And so because 3 times 1 over 3 is equal to 1. That's basically what we're doing here. So all we're left with is 1 over 3, which is equal to 3 to the negative 1. Because it's 1, you take the reciprocal of 3, which is 1/3, and then there was, the exponent was negative 1. We make it positive now. It's, you make it positive, so now it's just regular 1. So that's equal to 1 over 3 to the 1. So you get the same thing. So if you've expanded out, you used your rules for the negatives and expanded out what it actually meant that you were multiplying, and then you use your rules that we have, our properties of a number and multiplying by its reciprocal, they cancel out and equal to 1. And know how fractions work, where basically if you have a fraction, the top and the bottom can cancel out. You can see that you get the same answer. So that's why this rule exists. It comes about from just following previous rules that we have and what we know. And a lot of rules in math, this is what they do. You basically, you take your existing rule and you use those rules to make new rules. That's what math is all about. And they follow. It's very procedural. It's very systematic. And it's consistent. The rules all work. We don't like things that don't work and only work in some circumstances. We want them to apply all the time. So that's multiplication of like bases. Next property is division of like bases. So if you've got things that are divided, the exponents are subtracted. It's sort of the opposite. The opposite of multiplication is division. So with multiplication, we're adding exponents. The opposite of adding an exponent is subtracting an exponent. So it makes sense if you follow your rules what it means to be the opposite of something. And so I'm actually going to take our example that I have, the very last one here, 3 squared times 3 to the negative 3. Just to show how this rule also works with that. And I'm actually going to be smarter this time. I'm going to move on the left. 3 squared times 3 to the negative 3. So if I use my rule of exponents, that's 1 over 3 to the positive 3. I use my rule with the negative exponent. And if I use my rules for multiplying fractions that you multiply straight across, this is 3 squared over 3 cubed. So now I have written this in a division system, basically writing it as division, unlike the multiplication that I did here. It's the same problem, just writing it differently. So if I follow the rule that we have here, where you're taking the exponents and you subtract top minus bottom, the top exponent is 2, the bottom is 3. So 3, 2 minus 3, that's equal to -1. So we get 3 to the -1 power. That's the same answer we got here using the multiplication rule. So this is consistent. What this means is that the division rule basically follows the same, it's the same thing as the multiplication rule. It works the same, we get the same answer. It's consistent. So you can choose, depending on how something's written, you can choose whichever one makes sense. You'll get the same answer. And if it makes more sense to you, if we think about this rule again, 3 squared over 3 cubed, if I expanded it out, we have 3 times 3 on the top, 3 times 3 times 3 in the bottom. And if you start canceling things out, you're left with 1 in the denominator. When everything cancels out on top, that's 1. So you get 1/3, which is 3 to the -1 power from that definition of the negative exponent. So it's consistent. You can look at it in different ways and you get the same answer. So this rule works even if we have fractions with negative exponents. So if I had, let's say 3 to the 4th over 3 to the -2, what this means is you apply the rule of 3 and you do the top minus the bottom exponent. So we've got 4 minus a -2. So that's subtracting negative is adding. So that's the same as 4 plus 2, which gives you 6. So if we follow the rule, we would get an answer of 3 to the 6th. And this is consistent because if I have the same thing, 3 to the 4th over 3 to the -2, so because of this negative exponent thing, this is equal to 1 over 3 to the -2. And our rule with negative exponents is you take the reciprocal. So the reciprocal of 1/3 is 3, it'd be 3 over 1. And then you make the exponent positive. So if you have a negative exponent in the denominator, it kind of ends up in the numerator by being positive. So 3 to the 4th over 3 to the -2 is the same thing as 3 to the 4th times 3 to the 2 because of that rule of negative exponents. And then you use your rule for multiplication of like bases where you add the exponents and you get the same answer. So I'm showing you that we have all of these rules, they're all consistent. Whether you do it one way or another way, and this is one of the things that is hard about exponents, is that there are multiple ways to do a problem and get the same answer. And you can see that. I'm doing these problems using different rules and getting the same answer. But the key is you get the same answer. So you can take away from this is whatever rule you want to use that makes sense to you can do. You'll be consistent. So and you're seeing they're consistent, but you do need to make sure you have all these rules written down so that you can use them. So I'm going to go back and highlight these. I want to make you have these written down because then on a quiz and on the homework when you're using these rules, I've already got that one highlighted, you have them all in one place. So you're going to want to make sure you have these all in one place so you know what to do, what rules to have. So this next one we have is the power rule. And this is when you have an exponent and then another exponent. So you're taking an exponent to an exponent. You can see that I've got b to the m to the n. So there's 2 exponents there. The rule there is that you multiply them together. So if I have, let's say, 2 to the 5th, and then I have another exponent of 2, you multiply the exponents, and that's equal to 2 to the 10th power. And this comes about from if we expanded what 2 to the 5th means. 2 to the 5th, or 2 to the 5th squared, that's 2 to the 5th times 2 to the 5th. So that outer exponent of 2 is telling us that we have 2 of the insides. Make sure my 5 is a little better. And then if we use our rule for the multiplication of like bases that we already saw, when we use that property, you add the exponents, 5 plus 5, you get 2 to the 10. So this power rule comes about from using our prior rules. And so we basically notice a pattern, and like, okay, so it's basically you just multiply those. This works if you have a negative exponent. So if I have 2 to the 4 times, or to the power of -1, you multiply those exponents, you're going to get 2 to the -4. And even if you have something with the 0, 2 to the 3rd to the 0 power, multiply those exponents. 3 times 0 is 0, so that's 2 to the 0, and then that's just equal to 1. So if you have exponents on top of exponents, you multiply them. You can get this rule from following previous rules. Next one is power of a product. So it's basically, we've got now 2 things inside, and then we have a single exponent on the outside, ab to the m. And what this essentially means is that you can distribute the exponent from the outside to the inside, so that everything on the inside has that same exponent. With an example, and I know that it's always easier with numbers. So let me use different numbers there. I'll just put 4 out there. What this means is if you have something like 2 times 3 and then the 4th power, using this rule, everything gets that 4th power. So 2 gets the 4th, and 3 gets the 4th. So they each get that exponent of 4. It's distributed inside the parentheses so that everything has that exponent. So that's the power of a product. And that comes about from our other rules. So if I have 2 times 3 to the 4th, that means I have 2 times 3 4 times. That's what that means based off of the definition of an exponent. So we've got all of these things multiplied together, and so then if you count how many 2's do I have, well, I have 4 2's multiplied. And then you count how many 3's you have 4 of them. So if you expanded it out based off of what we know about exponents and the definition of an exponent, you can get the same answer. These properties, these rules of exponents are basically shortcuts so that you don't have to write the entire exponent out. You can use these rules to get shortcuts and get the answer immediately. And so this power of a product rule works if there's zeros, it works if there's negatives, it doesn't matter. It applies no matter what the exponent is. It applies no matter what the number on the inside is. I do want to, one that's usually tricky for people. Let's do something like this, -5 times 4 squared. So when negatives are in here, it's usually a little tricky for people and they get kind of messed up. So I would turn that negative to -1, because that's essentially -1 times 5 is -5. And you can use the rule even if you have 3 things multiplied together here. They don't have to be 2. You could have 5 things multiplied together. So you're going to distribute the exponent. And so I usually will just kind of use arrows to indicate that. So this is equal to the -1 gets the exponent of 2, 5 gets the exponent of 2, and 4 gets the exponent of 2. And I put them in parentheses just to be safe, just to make sure you've got everything written correctly. And this is even, you can put extra parentheses in Alex to make sure you've got the exponents on the right thing. Doing it this way helps you get the correct answer because usually those negatives mess people up. So you need to make sure if you keep the negative separate, that helps you keep track of the sign so you know whether you're supposed to get a positive or negative out. But this rule applies no matter how many things are multiplied on the inside. It just distributes across. And then you would basically put those in your calculator so that you can simplify it. Our last rule here, the last property, is power of a quotient. So that is basically, so quotient is another name for a fraction or division. And so we've got a fraction here with an outside exponent. So just like the previous rule, power of a product, power of a quotient, the exponent basically distributes. So everything gets that outside exponent. So if I had 1/2 to the -1 power, I have 1 to the -1 power, and then I have 2 to the -1 power. So everything gets that exponent. So I'm going to go back to that negative rule that I had. So I said that I was going to talk about this other way of writing 1 over a to the n, and we have 1 over a to the n, and then we don't have, you can write it with the n on only the a or on the thing with, as parentheses. Let me do an example here with this one. So if we had 1 over 3 squared. So using my power of a quotient rule, 1 is squared and the 3 is squared. 1 squared is equal to 1. So that's why the alternate way to write that was to put the exponent only in the denominator. And that works because 1 to any power is equal to 1. If you had a different number up there, like instead of 1 you had 2, it wouldn't work that way. So if I had 2/3 squared, I can't just ignore the top. I have to keep it as 2 squared over 3 squared because 2 squared is not equal to 1, it's equal to 4. It's a different number. So it's just a special thing with 1, that 1 to any exponent is equal to 1. And so sometimes you can kind of shortcut if you have 1 over something. So we've got 7 properties here. They are listed in the textbook. I've got, so I have a different version of the textbook open that I'm going to just pull over, just so you can see them. So they're all listed. This is in tables 2.1 and 2.2. This is in section 2.1, and they basically try to explain it in words, and then they're also giving examples. And they use examples here with variables. So I did examples with numbers because usually numbers are easier for people to understand, but they work with letters as well. So even if there's variables, the rule is the same. So don't let that freak you out. So just as an FYI, it works exactly the same way. So copying these down, making sure that you have my notes, have all the rules in like I would make a cheat sheet. Just have a single page where you put the rules, the definition or the property, and then some examples. That's what I would do for your own notes. Now the other thing I want to show, and I'm going to bring up Alex here. So give me a moment to log in. Because usually when people are doing stuff with exponents and Alex, I've seen issues where they're not being entered in correctly because it's just not really understanding how the thing kind of works. So let me just open one of these up. It's just taking a while. Don't mind me. Okay. Okay, so I have here, I opened up the exponential expression one just to kind of show you. Okay, so let's do a different problem. Let's try to find something a little simpler. None of these are all kind of practicing the rules. They're not like super simple. That's okay. What I just wanted to show you is so we've got this button here with the exponent. So if I want more than one thing inside that exponent, I have to make sure that I'd have to put parentheses. Now notice I'm trying to type parentheses and it won't let me. That tells me your answer should not have parentheses. So if you're trying to type something and it won't work, that is the system trying to tell you, oh, you don't need parentheses on this problem. So FYI, that's an indication you have an error. That doesn't mean the program's broken. So if I want to put an exponent, let's say just on the M, I can click and drag to highlight it, and then I can hit the exponent button, and then I can write my exponent. Let's say I'm going to have a 2. Now notice my cursor is up there at the 2. If I keep typing, I'm still in the exponent. I don't want to be in the exponent. You need to make sure you leave the exponent. So you have to hit the right arrow, and then you can see the cursor kind of move. So notice where the cursor is and the size of it. It's up in the exponent, and now it's down. So you need to make sure you move your cursor so that you can type the next part. If you don't, then you're going to have it typed in wrong, and it's going to mark it wrong because what you've written is not what you mean. Another trick is if you need to have a fraction and you want the whole thing in a fraction, you can highlight it and click the fraction button. So you can do that, and I'm just making up numbers. This is not going to be correct. Let's say you realize, oh, I missed it. I was supposed to have an exponent on the end. You can highlight it and you can go back and put that in. So if you missed it and you were like, shoot, I was supposed to have that there, you can do that. You can even click in the exponent and hit delete and change the number if you find an error. And you can even change the letter that's underneath there. Like if you messed up and that M wasn't supposed to be there, the exponent was supposed to be on the 4, you can delete that. And then this is just clearing it. So just be very careful when you're entering these things that you're making sure you know where your cursor is. Watch where it's flashing. Because the biggest errors I've seen with this is people having their cursor in the wrong spot. So you want to make sure before you check your answer that everything is exactly where you want it, that you're using the correct letters. Just a side note, capital M is different from lowercase m. In math, that makes a difference. The capitalization matters. So you can't switch and write a capital M instead of a lowercase m. That's going to get you the wrong answer. So you need to make sure everything looks exactly as you want it to. Because otherwise it's going to be marked wrong. Because math is one of those things where you have to pay attention to everything. And so what you're writing in this box is the final answer. So you're going to have to do all of your answers on paper first, and then you write your final answer here. I'm going to actually try to do this one in my head. I don't know if it's going to allow me to keep it as 4 to the 4th. So that's negative 12 plus 4, that's negative 8. So that's going to be in a fraction. And you can even do exponents in the fraction. 3 plus 16, so that's going to be n. I'm trying to do this in my head, so I could be totally wrong. Let's see. Okay, so notice that there's these little 3 things, and it kind of gives you a hint what you did wrong. So it says your answer is incorrect. The coefficient can be simplified further. So that's telling me it doesn't want me to leave it as 4 to the 4th. It wants me to actually figure out what 4 to the 4th power is equal to. So 4 cubed is 64. I think it's 128 maybe. I'm trying to do that in my head. No. Okay, so it might be 256. I'm going to actually grab my calculator for 4 to the 4. And so notice here it's an X. So the X means it's totally wrong. The 3 dots meant it was wrong, but it was it was correct, but in the wrong form. Okay, yeah, this is supposed to be 256. So those little symbols, they help you. So pay attention to those as well. Okay. So that's something to know is like, okay, you need to actually then put if it's a number, you want to put it on your calculator to figure out what it is. So that's an overview of all of the rules or the properties of exponents and how they work. These problems for the homework assignment is trying to combine all of these to simplify. So you're now applying all of the rules to follow the simplification process. And the general rule is it's sort of the same as following the order of operations. Is you want to multiply any exponents before you add exponents. So if you use those general guidelines, that's going to help you. And I'm actually going to pull over. So I have in my week 2 links, so we've got the video link video link right there in week 2. This would be the video that you would watch next, simplifying exponential expressions, because now I'm applying the rules and showing you how to simplify these things. So this would be what I would watch next when you're ready, and then watch this before you do that second homework on the expressions. And if you need to see this bigger, because it doesn't let you do full screen in here, just click on the name, and then that will open it up into YouTube, and then you can do that. You can watch it on YouTube and go to full screen. So there we go. And I'm trying to pause it, but it's having problems loading. There we go. So I have a little brief overview of the rules. Yeah, it's taking a really long time to load. Right there. So I've got an overview and I have an extra rule here. And then, yeah, and then I just have lots of rules. So are there any questions? Do you have any questions on any of that? If not, that's totally cool.
Say, yeah.
Okay.
Probably when I